So we want to wrap up this unit on rational functions and rational expressions and talk about how to solve equations that have rational expressions in them. And so first we want to talk about proportions. You've done proportions before. Most people think about proportions, oh, it's the relationship between how much bigger something is than something else. And we have an idea what proportions are. But when it really algebraically breaks down to is a proportion is one rational expression equal to another rational expression. So there are two rational expressions that happen to have the same value. Reduced fractions. They're the same value, they just have different numbers on the top and the bottom. And so when we have proportions, we are dealing with rational expressions. So this is at least equations that you have solved before with rational expressions. So we want to start there. So if we look at something like -7 over 2p minus 10 is equal to -10 over p plus 4. This is a proportion. It is important to point out that a proportion is one rational expression equivalent to one rational expression. There can be nothing added or subtracted out here off of the rational expressions. You can have addition and subtraction inside of the rational expressions, but you can't have things, hanging on outside the rational expressions. Then it's not a proportion. So when we're dealing with a proportion, I'm sure in the past you have been taught to cross multiply. And that still works with these types of proportions. And you can still do that. So you want to remember when you are cross multiplying though, or all you're really doing is multiplying both sides by this denominator. When I multiply this side by p plus 4, the p plus 4 happens to just cancel out. And then when I multiply this side by it, I actually end up having to multiply the numerator by p plus 4. And then when I'm doing the cross multiplication up here, I'm just multiplying by this denominator. And so when I multiply this side by 2p minus 10, it cancels out. But then when I multiply by 2p minus 10 over here, I end up having to multiply this side. So we're still sticking to that rule that we are just multiplying by the LCM of the denominator. And that's just kind of the golden rule of dealing with fractions. The best way to deal with fractions is to get rid of the fractions. And when it comes to solving rational expressions, it's our only option. As long as it's still a rational expression, we cannot isolate the variable. So we have to make sure that whatever we do to this equation, we have to get rid of the rational aspect of it. We have to be able to get that variable out of the denominator or we will not be able to solve it. Now, the way we do that is to multiply by the LCM of the denominators. It just so happens that in proportions, that's cross multiplying. That's kind of been this trick that we always just learned or people were taught and said, well, that's how you fix this problem. But what you're really doing is multiplying by the LCM. So I end up with -7 times p plus 4 is equal to -10 times 2p minus 10. And then I no longer have rational expressions. Now, when you do multiply by the LCM of the denominator, there's a lot of things you have to remember. You have to make sure you distribute. That's going to be very important. You're going to end up with all kinds of different types of equations. You might end up with linear equations. You could end up with any number of polynomial equations, quadratics or cubics. And so that's why we learned about polynomials before, because ultimately when you're solving equations that have rational expressions in them, you're going to end up with a polynomial. And so you just have to remember all of your rules for solving polynomial equations. So this is going to be -7p plus -28. And then here I have -20p, and a negative times a negative is going to be +100. So this one did turn out to be linear at least. I don't have any p squareds. So if I add 20p to both sides, and I add 28 to both sides, I end up with 13p is equal to 128 and divide by 13. So p is equal to 128 over 13. As always, exact answers are best, but with IXL, just make sure you read your directions. If they want it rounded to a certain decimal place, make sure you actually round it to that decimal place. Otherwise, just leave it as an improper fraction. This doesn't reduce. You do always want to reduce your fractions, but this one doesn't reduce. We also want to check for extraneous solutions. We've run into these before. If you recall, when we did exponentials and logs and different equations, that sometimes we end up with a polynomial or some other type of equation that can have multiple answers, but one of those answers doesn't work or none of the answers actually work. And it's because we're dealing with a function that has a restriction. Anytime square root functions, logarithmic functions, anytime you're dealing with functions that have a restriction, numbers that aren't allowed to be part of that function, you have to watch out for extraneous solutions. In this particular problem, we have p in the denominator, so there's certain numbers p cannot be, because then we'd be dividing by 0. For example, p could not equal -4, and here p could not equal 5. Because if it did, then we would be dividing by 0. So you just always want to check and make sure that your answer is not one of those numbers that's not allowed. And in this case, it's not. 128/13 is not going to give us 0 in the denominator, so it's perfectly fine. But you do want to make sure that you're watching out for extraneous solutions. Another example, 12/x+3 is equal to x minus 5/x. So again, we're going to multiply by the LCM of the denominators, but for proportions, that means I just end up cross multiplying. So 12 times x is 12x. But I do want to point out that if I'm taking x plus 3 and I'm multiplying it times x minus 5, you can't just multiply first terms and second terms. Don't forget, when we multiply binomials, we have to double distribute, use the area model. You have to multiply it out. And so that's going to give us x squared minus 2x minus 15, which does give us a quadratic equation that we're dealing with. So now I am dealing with a quadratic. I know quadratics have to be equal to 0, so I'm going to subtract 12x from both sides. And now I have it equal to 0, because we know to solve quadratic equations, no matter the many options we have for doing that, they do have to be equal to 0. So now that we have that quadratic equal to 0, solve by any of the methods that you like to solve. I'm going to try and factor it. Two numbers that multiplied equal -15 and add to equal -14 are -15 and +1. So x equals 15 and x equals -1. Now I do want to check and make sure that neither of these numbers give me 0 in the denominator. It doesn't here and it doesn't here. So both of these numbers will actually work in this proportion. I have no extraneous solutions.